When the Voyager probes were launched in 1977, scientists believed that once they crossed the boundary of the heliosphere, known as the Hercules columns, they would enter an empty, desolate space with little to observe. Instead, the interstellar void turned out to be an endless source of new phenomena, challenging previous assumptions about the nature of space beyond our solar system. The history of the Voyager missions. NASA launched the twin spacecraft, Voyager 1 and Voyager 2, as part of an ambitious mission to explore the outer planets and beyond. Taking advantage of a rare planetary alignment, Voyager 2 became the only spacecraft to visit Uranus and Neptune after successfully flying by Jupiter in 1979 and Saturn in 1981. Meanwhile, Voyager 1 followed a faster trajectory, reaching Jupiter in 1979 and Saturn in 1981-1980 before heading towards interstellar space. Voyager 1 became the first human-made object to cross the heliosphere in 2012, followed by Voyager 2 in 2018. Despite their initial goal of planetary exploration, both spacecraft continued their mission, sending valuable data back to Earth. In 1990, Voyager 1 captured the iconic pale blue dot image, showing Earth as a tiny speck in the cosmos. The mission has since evolved into the study of interstellar space, providing groundbreaking insights into the universe beyond our solar system. Cosmic tsunami. Shock waves from the Sun. One of the most fascinating discoveries made by the Voyager probes is the presence of a cosmic tsunami, shock waves caused by powerful solar outbursts. In 2014, a massive solar flare created a surge of plasma that traveled through the solar system, reaching Earth within 2 days. This wave continued outward, eventually hitting Voyager 2 in 2015, while still inside the heliosphere, and finally reaching Voyager 1 in interstellar space in 2017. The most intriguing part of this event was the detection of an unexpected burst of electrons arriving at the probes weeks before the shock wave itself. This suggests that the shock wave was accelerating electrons to near-light speeds, a process that had only been theorized but never directly observed. These findings could help scientists better understand cosmic radiation and the dangers posed by similar shock waves to astronauts on future space missions. The Wall of Fire. Another groundbreaking discovery was the detection of a mysterious wall of fire just outside the heliosphere. Instead of space becoming emptier as expected, Voyager 2 found that the density of plasma actually increased significantly. This suggests that the transition from the solar system to interstellar space is marked by a boundary of highly energized plasma, a finding that was corroborated by Voyager 1. Understanding this transition zone is crucial for future deep space missions and for studying how our Sun interacts with the galaxy. The Voyager probes, humanity's messengers. Both Voyager spacecraft carry a special cargo, the Golden Records. These records contain sounds, images, and music representing Earth and human civilization, intended for any potential extraterrestrial life that may one day encounter them. As the probes continue their endless journey through space, they serve as both scientific instruments and symbolic ambassadors of humanity. The final years of the Voyager mission. With each passing year, the power supply of the Voyagers diminishes. Their radioisotope thermoelectric generators, powered by plutonium-238, lose about 4 watts of power annually. To conserve energy, mission engineers have begun shutting down non-essential instruments, prioritizing scientific tools that provide the most valuable data. Critical systems such as the orientation mechanism that ensures communication with Earth remain operational, but only for as long as the dwindling power allows. Despite their increasing limitations, the Voyagers continue to provide crucial insights into interstellar space. NASA's upcoming Interstellar Mapping and Acceleration Probe, IMAP, scheduled for launch in 2025, will further investigate these phenomena. However, for now, the Voyager probes remain our only active explorers of the space beyond the solar system. Eventually, the Voyagers will lose contact with Earth, drifting silently through the cosmos as interstellar messengers. Their journey, once a bold scientific endeavor, will become a testament to human curiosity and ingenuity. They will continue their voyage through the galaxy, carrying a message from Earth to the unknown, like seeds cast into the cosmic wind. Their discoveries have reshaped our understanding of the universe, proving that even at the edge of the solar system, the cosmos is far from empty. And long after they fall silent, their legacy will endure, inspiring future generations to reach for the stars. The Wall of Fire. Beyond the solar system. The boundary of our solar system holds a fascinating and somewhat ominous feature: a wall of fire. This fiery barrier is caused by electromagnetic radiation, generated by plasma and an environment filled with intense magnetic fields. While this posed a significant challenge for NASA's Voyager probes, it also validated the decision to launch 2 spacecraft to explore the universe. If the wall of fire were only in one localized region, a single probe might not have detected it. Instead, Voyager 1 and 2 confirmed that this phenomenon extends across the outer edges of the solar system, discovering the plasma barrier. The Voyager probes are showing us how our Sun interacts with the stuff that fills most of the space between stars in the Milky Way galaxy, said Ed Stone, project scientist for Voyager and a professor of physics at Caltech. Without this data from Voyager 2, we wouldn't know if what we were seeing with Voyager 1 was characteristic of the entire heliosphere or specific just to the location and time when it crossed. Plasma, the fourth state of matter, was always believed to exist outside the heliosphere due to solar emissions and interstellar material interactions. Voyager 1 detected slightly higher plasma levels upon entering interstellar space, but Voyager 2 revealed that the plasma presence was far greater than expected. Plasma is extremely hot, and while this wall of fire is cooler than the Sun's plasma, it is still hot enough to pose risks to spacecraft and future explorers. Moreover, the plasma is dense, forming a formidable boundary that must be carefully navigated. This discovery raises a crucial question. If there is one plasma wall, could there be others elsewhere in the universe? If so, exploring space might require even greater technological advancements than previously thought. The fact that we underestimated the plasma density in this region suggests that our assumptions about the outer solar system need reevaluation. What else might we be wrong about? The leaky heliosphere. One of the most unexpected findings from Voyager 2 was that the heliosphere, the protective bubble of solar winds surrounding our solar system, appears to be leaking particles. This should not happen under normal circumstances, as gravity and solar winds typically keep particles contained. However, Voyager 2 detected particles escaping, indicating that the heliosphere might be contributing to the growth of the wall of fire. Since the 2 Voyager probes are positioned at different locations, one near the front and the other near the side of the heliosphere, it is possible that this leakage is occurring in multiple regions. If this process continues, the wall of fire could expand, potentially impacting the heliosphere itself. While this discovery excites scientists, it also underscores the need to monitor and understand the heliosphere's long-term behavior. If the plasma barrier grows unchecked, it could have significant implications for future space exploration. Magnetic fields in interstellar space. NASA scientists were also intrigued by unexpected findings regarding the magnetic fields beyond our solar system. Our solar system exists within a magnetic field primarily shaped by the Sun, similar to how planets orbit the Sun due to gravity. Scientists initially believed that once a spacecraft exited the heliosphere, it would encounter a vastly different magnetic field orientation. However, Voyager 1 and 2 disproved this assumption. Voyager 1 first detected irregularities in the interstellar magnetic field. Later, Voyager 2 confirmed that this field runs parallel to the heliosphere's boundary, a discovery that left many scientists puzzled. Understanding this alignment is essential for grasping how cosmic forces interact on a galactic scale. Communicating with the probes. Given their vast distance from Earth, how do we maintain communication with the Voyager probes? The answer lies in NASA's Deep Space Network, DSN, a series of radio antennas positioned worldwide. This network transmits signals to the probes, receives data, and relays it to the Jet Propulsion Laboratory, JOPL, in Pasadena, California, where scientists analyze the information. One of the most intriguing findings from Voyager 1 was the detection of plasma waves in interstellar space. These waves exist as vibrations in sparse interstellar gas, producing a hum that scientists have converted into an audible signal. If we could hear it, the sound would resemble a steady note, subtly shifting over time. Maintaining communication with the probes is vital for scientific discoveries. For example, in 2020, Voyager 1 detected an electron burst, high-speed cosmic ray electrons accelerated by shock waves from solar eruptions. These particles move along magnetic field lines at nearly the speed of light. Understanding such phenomena is crucial for space travel, as radiation exposure poses risks to astronauts and spacecraft. The Voyager legacy. The Voyager probes have been operating for decades, continuously sending back data that reshapes our understanding of space. When they launched, no one could have predicted the breadth of their discoveries. Plasma walls, interstellar radiation bursts, and unexpected magnetic field behaviors are just the beginning. Each new transmission provides a clearer picture of the universe and what awaits us beyond our solar system. The Family Portrait. In addition to their scientific achievements, the Voyager probes have captured breathtaking images of our solar system. On February 14, 1990, Voyager 1 took the famous Family Portrait, a collection of images showing the planets from the probe's vantage point at the edge of the solar system. At a distance of 6.4 billion kilometers, 4 billion miles, from Earth, even massive planets like Jupiter appeared as tiny dots, while Earth was just a pale blue dot, a humbling reminder of our place in the cosmos. Though some planets were obscured due to the sun's brightness, the portrait symbolized the vastness of space and the endless possibilities beyond our solar system. Even today, it remains one of the most iconic space photographs ever taken. Looking ahead. The universe is vast, and our exploration is only beginning. The more we learn, the better we can prepare for humanity's future among the stars. The Voyager probes continue to provide invaluable insights, proving that even decades-old spacecraft can still push the boundaries of human knowledge. What do you think about these discoveries? Are the Voyager probes among the most significant tools for space research? Let us know your thoughts, and stay tuned for more fascinating space exploration updates.